Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with modeling diagnostics, and that too the coverage is on multicollinearity problem. In the last couple of lectures we have already discussed this particular component, that is the multicollinearity problem. In the simple language, multicollinearity is a multivariate problems where the issue is to know the existence of linear relationship among the regressors. As per the regression modeling requirement or the requirement of ordinary least square mechanism, there should not be any correlation among the regressors, but in reality when we will be dealing with a real life problems, any kind of engineering problems, you will find most of the variables are more or less correlated. Our job is to check how is the degree of correlation among the regressors and how what extent we can tolerate and what extent we like to change it level of modeling, so that the problem of multicollinearity can be minimized and the estimated model can be used for the prediction and forecasting. So, so the problem will be more and more interesting when the number of regressors are very high. So, we can start with a simple structure and then we will analyze how is this particular complexity and ultimately how we can get the kind of solution. In the last lecture specifically, we have discussed the nature of the multicollinearity, the kind of detection criteria and the kind of solution. So, we have by the way we know what is exactly multicollinearity, and we know how to detect the kind of multicollinearity, and also we have gone through certain structure through which you can also solve the multicollinearity, not completely zero relationship among the regressors, but somehow we have discussed something how to minimize this particular problems in order to justify that the estimated model can be used for the prediction and forecasting. So, the solutions which we have discussed earlier are like this. First you can increase the sample size, you can drop the collinear variable, you can change the functional form, you can change the structure of the problem. We can use different techniques like factor analysis, principal component analysis. So, like we have couple of mechanisms through which you can actually solve the multicollinearity problem, but these are all kind of very supportive kind of structure through which we without any change of the modeling structure, still we like to solve the multicollinearity problem, that to minimize the problems in such a way that the model can be used for the prediction and forecasting. But when the problem is too complex, so increasing sample size, decreasing sample size, or change of functional form, change of the structure of the problems, so we will not solve the problem. Even use of some other technique also may not solve the problem. So, ultimately we have two different extremes, what we can call. One is called as the use of techniques like principal component and factor analysis, which is very specifically used to to drop the variables, means to reduce the variable in some extent, because the literary meaning of factor analysis is that it brings a new cluster which is smaller than the original cluster, and the new cluster will be the linear combination of the original one. So, that means like instead of using 20 variables, we can have 4 to 5 factors, and these 5 factors are linear combination of these 20 variables. Somehow we have to fix in such a way these factors can club in or connect to these 20 variables. So, that the problem of multi-collinearity by default will be solved, and usually factor analysis is applied to solve the multi-collinearity problem, and in another extent when your sample size is lesser enough than the number of variables. So, we can use also factor analysis, and besides factor analysis and that to the use of principal component analysis, one of the strongest mechanism to solve the multi-collinearity problem is to use the stepwise regression. So, usually we use stepwise regression where the that is the last step of the particular process, when other options are not actually it can be helpful to solve this particular problem. So, ultimately last step is the use of stepwise regression, and this lectures specifically will talking about the stepwise regression, because it is one of the fantastic kind of structure through which we can solve the multi-collinearity problem, and we can bring a particular estimated model which is exclusively very useful for the prediction and forecasting. So far as stepwise regression is concerned, it is a step by step process, and what is that step by step process? We have two different structure altogether. One particular structure is called as a forward integration mechanism, and the other one is called as a backward integration mechanism. In the forward integration mechanism, we start with dependent variable to independent variable, one independent variable, then subsequently you can add one after another independent variables, and then in the same times you have to check the model, there is improvement of the model, and finally you have to stop where the model the addition of new variable will not improve the estimated model. So, that is how the process of forward mechanism. In the backward mechanism, we start with the full model, then you try to drop one after another variable, and in the same times you check whether the estimated model will be coming something good or something best compared to the previous one. Then you will stop at a particular point of time where the model will be considered as the best to go for the kind of prediction and forecasting. So, what will you do? So, let me give you the kind of snapshots, how is the kind of backward process and how is the kind of forward process, and how you can proceed step by step. For instance, so we can start with 5 variables. So, this is what the 5 variable case, which we have already discussed in the last lecture. So, when you have 5 variables, so without any hint, you just allow the software to have the estimated model, that too with full setup. So, if you say full setup, then it is nothing but called as y equal to simply a function of x 1, x 2, x 3, then okay, this is something coming wrong. Okay, so I will write here y equal to function of x 1, x 2, then x 3, x 4 and x 5. Okay, so this is the full model, and as usual, so the model can be structured like this. You can formulate the model like this: y equal to beta 0 summation beta I x I equal to 1 to 5, and this is plus error term. So, this is how the multivariate model or multiple regression model with the 5 variables, but ultimately this is what actually in the form of mathematical structure, and we need actually the estimated structure or the kind of model which we can use for the prediction and forecasting. So, when we talk about the first model, then by default means the original estimated model. So, then you have the structure like y equal to beta 0 plus beta 1 x 1, beta 2 x 2, beta 3 x 3, beta 4 x 4, beta 5 x 5. Now, once you have the full estimated model with full setups, that means y with all these 5 independent variables, then you first check whether the model is okay or not, okay in the sense that is with respect to multicollinearity. So, the eye inspection is that if the model is okay, then most of the variables or all the variables should be statistically significant, and the goodness of fit of the model will be also very high. That is just through the component called as coefficient of determination, that is R square. So, ultimately in the first instance model can be considered as the best if all these parameters or all the variables are statistically significant, and overall fitness of the model will be also very good, that is indicated by R square, capital R square, that is the coefficient of determination. So, now the chance of multicollinearity will arise when R square will be high, but most of the variables are not significant. The vice versa is also true. When most of the variables are statistically significant, R square is low. But what is the best, or what should be the kind of typical structure? Now, when R square will be high, most of the variables should be statistically significant. When R square will be low, then there is means it is not necessary that all the variables will be statistically significant, but at least few variables should be statistically significant. If no variables are statistically significant, then we should not use, even R square is also high, that means goodness of it will be very high. So, we will choose a situation where most of the variables are statistically significant and R square will be also very high. But if other way around, R square high and few t ratios are significant and all t ratios are significant, R square are low. So, in that case or in those two situations, we can expect that there is a kind of multicollinearity problem. But if all the variables are statistically significant, R square is fairly high, and most of the variables are not significant, or very few variables are significant, and in the same times R square is low, then the even the model is not good, but still the chance of multicollinearity is not arise. So, but the in between the situation when R square is high and most of the variables are not significant, and most of the variables are significant when R square is low. So, these are the two instances without any check, there is in fact there are criteria how to detect the multicollinearity, which we have already discussed, like variance inflating factors or something like tolerance factors. So many components we have discussed through which you can detect the multicollinearity problem or the degree of multicollinearity. For instance, VIF, if the VIF value will cross 10, then by default there is a multicollinearity problem, and that to severe multicollinearity. If VIF factor is less than 10, there is a kind of multicollinearity, but it is less severe, and it is close to 0 means very low multicollinearity, and 10 above means the degree of multicollinearity will start increasing. So, now assuming that this problem is having actually multicollinearity problem, then we have tried here and there by using the sample increasing mechanism or sample decreasing mechanism, or some of the other components, data transformations, change of the functional form. By using all these criteria, we are not in a position to get estimated models which is good and used for the prediction and forecasting. In that context, what will we do? So, we will go by stepwise regressions, and then to find out which one is the best model and what are the variables actually should be included in the system, so that the model can be used for the prediction and forecasting. Ultimately, the prediction is about the dependent variable, whether we are including all the independent variables or we are including few independent variables, that is not big deal, but ultimately while predicting dependent variables, your model estimated model should be reliable and is good for the estimation and predictions. Even if you are including actually 5 variables and variables are not significant, then that model should not be used for the prediction and forecasting. Instead of using 5 variables, if your model is having only 2 variables or 3 variables, then and all these variables are statistical significant, still that model can be used for the prediction and forecasting. Without looking the statistical result or econometric results, the theoretical understanding is that if more number of variables are involved in the process, then the prediction accuracy will be very high, but that should be supported by the data and the kind of estimated models. It is not always true that more the variables, good is the consistency of the prediction. It is the prime conditions or necessary condition, but the second is a sufficient condition or secondary condition is that. So, you have to fix a model, and that model should be used for the prediction and forecasting, where the variables should be statistically significant. And stepwise is a kind of mechanisms. By default, it will operate in such a way only significant variables will be in the systems, and the remaining variables by default will be out in the system. That is the beauty of this particular technique. So, that means how to start this particular stepwise process and how to end this stepwise process. Yes, the term stepwise itself indicates that it is a step by step process, but how is the step by step process and how we can actually move one point to another point. In management language, it is like it is a question of opportunity cost. So, it is the comparison with means the stepwise regression will give you indication that there will be alternatives, and you have to choose the best, then by default the other one will be kicked out. So, that is how we have to actually follow the particular mechanism, and then finally, we choose a model which is good for the prediction and forecasting. So, it is theoretically again very clear about the kind of structure, the understanding, but practically how you have to deal with this kind of problems, and how you have to use the stepwise and come to the kind of conclusion. That is very interesting, and that is the key actually to follow. Okay. So, what will you do in the stepwise process? So, I will start with first forward, and then I will go to the backward. In the forward process, so you start running the full model, and then check which one is the most most significant and most important variable, and that will be decided through the significance of the t ratio and the value of the t ratio. For instance, beta 1 x 1 beta 2 x 2, I can say x 1 is more important than x 2, provided both are significant, but the value of beta 1 is much higher compared to beta 2. So, then beta x 1 can be considered as the most important variable. So, that means technically we like to see which one is the most important variable to predict the y. So, when we are running the multiple regression, then we will find estimated coefficients, we will find standard errors, we will find the kind of t coefficients. So, let me give an examples. So, this is what actually the software till now which we have used is called as Excel spreadsheet, and that too there is a data analysis package, and from the data analysis package we can actually go to the regression, and then we are building the models and getting the kind of solution. But now I will be solving the same problem with different softwares. So, what will you do? So, you simply actually I am closing this particular software now. I will start fresh. Okay. So, this is a software econometry software called as a Gretel, and it is a free software, and you just download and install, and like R, it is very easy, and here you need not require to write programming. It is a window based software, just install, and it will be helpful for the entire the particular subject. So, the box of the Gretel will look like this, and what will it do? Whatever we have discussed right now, starting with the bivariate, multiple regressions, and the problems associated with multiple regressions. That means, there are two step process altogether till now. The the kind of foundations, that is what is the exact objective to predict or the kind of forecasting. So, it should be followed by variables identification, data availability, then you have to build a functional form, then we use the software, or you can go by the manual process. Ultimately, we need a estimated model which can use for the prediction and forecasting of the dependent variable. So, we have gone through the bivariate process, we have gone through multiple regression process, but every times whether it is a bivariate, trivariate or multivariate. So, once the problem is clear, data is available, and by the help of Wallace mechanism you get the estimated model. Then ultimately, after getting the estimated model, we have to check whether the model is actually okay or not. So, for that we have gone through specification test, goodness of fit test, and then the diagnostic test, which we are going through the kind of multi-collinearity problem and some of the other components, but right now we have discussed up to multi-collinearity problem. So, bivariate and then trivariate and multivariate, and then passes through all the tests like specification test, goodness fit test and diagnostic test. So, what I will do, I will pick up a particular problem and then I will handle how the estimations are coming, and finally, how to detect the multi-collinearity problem, and again how to get the revised models where the multi-collinearity problem will not be there. So, what will it do? So, in like regression Excel package, you have to just go and install the data analysis package, then you ask the menu bar to go for the regressions and then indicate the dependent and independent variables, and finally, you will get the estimated output with all these specification parameters, goodness fit parameters, and the diagnostic part of this particular problem specifically directly not visible. So, you have to understand first, then slightly you have to check yourself, then try to improve or try to minimize all these problems as much as possible. But specification test, goodness fit test, by default estimated model will give you some outputs like beta parameters, then standard error of the beta parameter, t statistic, then R square, adjusted R square, coefficient of F statistics. So, so there is a component called as adjusted R square. So, when you add one after another variable into the system, then R square will start means increasing indefinitely, and because it will not adjust the degree of freedom, but when we actually use adjusted R square, then the variables involvement and sample size will be adjusted simultaneously. Then finally, it will give you a particular component which is called as adjusted R square, and that will be used as a goodness fit indicator for the judgment of the estimated models or the reliability of the model. So, ultimately how to go about this particular process. So, let us say this is a menu bar, and we have here actually some kind of data set. So, I am just bringing this data set to this particular box, and the moment I will be bringing, then it will come, the transformation will be like this. You just put OK, and the menu bar will ask you the imported data have been interpreted as undated, and that is cross sectional. Do you want to give the data a time series or penal interpretation? What we have already discussed, this is how the message will come in the toolbar. So, ultimately when you allow the software to estimate, then software definitely will ask whether the particular data set is the cross sectional type or time series type, pool type or penal type. In fact, this grid will ask you only three things: cross sectional, time and penal. So, when you import the data, by default it will read as cross sectional data, and if your actual data is time series, then you specify the time series, then you indicate the time series which range to which range, because there is need of consistency. And again, when there is a kind of penal data, again you have to give the command up to how many years and for how many country. So, you have to give the indication. Then after that, the software by default will read as a penal data or time series data or cross sectional data. Then it will help you to solve the problem very easily. So, now let us assume that we have this data and we are actually just imported, and software is asking whether it is a cross sectional data or you have to give time time indications or panel indications. So, let us say no. So, that means if you say no, then the software will read the data that it is a cross sectional type, then you will go for the estimation. And if you go for the estimation, if you again go to the toolbar, then you will find there are many items: file, tool, data, view, add, samples, variables and model. Ultimately, this is a regression modeling, and this package is exclusively for regression modeling. And you will find a model, and you click the model, you will find plenty of options are there, starting with the ordinary least squares, instrumental variables, other linear models, limited dependent variable models. These are all things will be coming over the time, but in the first instance till now whatever we have discussed, it is mostly because mostly with respect to OLS mechanisms, that is ordinary least squares. And if in this menu bar the first option is the ordinary least squares. So, you have to just click actually, and that is whatever we have discussed till now, it is only on the basis of OLS mechanism only. And OLS technique has its limitation, that these are all called as assumption of OLS, and we are testing all these assumptions, and these tests will give you the diagnostics or something kind of reliability of the estimate. If all these assumptions are not satisfied with OLS criteria, then the OLS estimated results will not be used for the prediction and forecasting. So, so that is how we are in the process of testing and doing the things. So, now after importing the data, allowing the software to read as a cross sectional data, then you choose a models, that is through OLS mechanism, that means up to whatever we have already discussed is through OLS, whether it is a bivariate, trivariate or multivariate, but every times we are discussing with the OLS up to till now. And in this case there are couple of variables in the left hand side box, and if you see in the Excel package and this Grittel package, you will find drastic difference. In the Excel spreadsheet we have the regression package, just click and indicate the variables. Again in the same box, in the upper one is the dependent variables, lower one is the independent variable, but here the box is slightly different. In the left hand side it will give you the indication about the input box, and in the right side you will see here, in the right side this is the bar and this is the input box and this is the command box, where you have to give the command, then automatically software will process the output. So, in the input box you have the variable indication. Now, in the right hand side of this circles, you will find there are two different box. One box is a dependent variable, which is a smaller one, then there is actually regressors box, which is actually bigger one. So, the smaller one, because it is the dependent variables, and every times whether it is a bivariate, trivariate and multiple, so you have only one dependent variable. So, that is how the box is a very small one. So, you just allow the particular dependent variable to that box, and then the rest of the independent variables should come to this area. So, then you allow the software to go ahead with the estimation process, because when you use any software, so it is you to actually give the command and process the kind of software automatically will not read all the instruction. So, it is you to rotate actually the kind of process. So, what we will do here? So, we will just clean, and then you put actually, let us say price is a kind of variable. This is a civil engineering problem, and that too housing price determination. What are the factors which can actually affect the housing price? So, there are many factors which can actually affect the housing price, that depends upon size of the house, the kind of facility of the house, distance from the market, distance from the kind of sea area, then how is the kind of locations, flooded location or something like that. Likewise, we have actually different variables identified, and that too on the basis of theory, and then you allow actually the kind of all these variable to the input box. So, you will find all these input box coming like this, food, okay, distance, okay. So, the all these independent variable now in the box, command box, and then allow the software to run the model. So, you just put OK, and by default okay. So, dependent variable is not allowed. So, now so dependent variable is fixed and independent variables are fixed. Now, you put OK. So, now after putting the OK, you will find this is what the regression result. You will find plenty of regressions see here. So, as usual, so these are all variable indication. These are all variable indication. This is the coefficient, beta coefficient, and these are all standard error of the beta coefficient, and these are all t statistics, and this is the probability level of significance. So, now most of the variables, I mean say most of the occasions you like to check the significance of variables at 3 levels, 1%, 5% and 10%. Okay, 10%. So, what will it do ultimately? A 1%, 2%, 5% and 10%. Any variable is statistically significant 1% means it is the best. If not, then that we can check at 5%. If you cannot, then again you can go to the 10%. So, that means if variable is significant and 1%, it is the best. If not, then 5% is the best. If not, then 10% will be the final choice. Then after that, statistically we cannot go proceed further, but software will give you the exact probability level through which you can actually reject the true null hypothesis. So, what we can do here? So, already software calculated everything. So, these are all beta coefficient for variables, independent variables, and these are all standard errors and coefficients and standard errors and t statistic and the p value. So, now you will find this model is actually very good ones, in the sense most of the variables are actually statistically significant, except the last variable, which is actually distance according to the housing price. So, that means technically since and then this gives significance of the parameters or significance of the variable. Since most of the variables are statistically significant, then R square should be very high, and this will be followed by this is why actually followed by 0.75, which is actually good enough, and corresponding to R square, adjusted R square is also 0.67. So, adjusted R square, actually we know R square is actually ratio between explained sum of squares by total sum of the square TSS, and then adjusted R square is nothing but 1 minus R square 1 minus R square into n minus 1 by n minus k. So, this is what the on the basis of formula you can calculate, and ultimately a software will help you to get this particular value. So, this is R square and this is the adjustment vectors. Otherwise, R square will start increasing when we add one after another variable into the system, because ESS is nothing but actually weightage of independent variable. For instance, if it is bivariate, then the weightage will be summation y x 1 by TSS. When it is trivariate, then summation y x 1 plus summation y x 2 divided by TSS. So, that means TSS the lower part will be remain constant. So, when you add one after another variable, the first variable weight will be 1, then you add another variable, then some additional variable weight will be added. So, that means technically upper side will start increasing, because the component ESS is always actually positive 1. So, as a result, any new variable means it will be a positive support to the impact. So, as a result, the ratio will be very high when you add one after another variable into the system. That means technically R square will be very high. So, that is why when we have more number of variables or multiple regressions or multivariate regression, R square is not used as a good indicator for the model judgment. In that case, adjusted R square, that is the which is calculated like this, will be used for the prediction and forecasting. So, now ultimately in these models only one variable is not significant. So, that is why you may not go for stepwise. to follow the particular process. But if you I will tell you the exact structure when you need actually stepwise. Even if this model can be used stepwise, because one way we can use that since different variables have a different significance level. So, we like to fix a model where all the variables will be statistically at 1%. This is another way to use this stepwise, or else most of the variables are not statistical significant, still you use stepwise to find out the situation how to actually deal with the problem. So, in that context what will you do? So, you see here, so this column you have to actually target. So, this column will give you the indication that which variable is having very high impact to the dependent variable. That depends upon value of t ratio. Higher the value of t ratio, higher is the impact, lower the t value, lower impact. So, that means without actually checking the sign, because whether positive negative that is not a matter is which one is more impact towards the dependent variable. So, it depends it exclusively depends on the value of the t statistics. So, that means technically after the estimations you just check all the beta coefficient and the t value of this beta coefficient, which one is the highest. So, that model will come that variable will come first in the estimation process. So, this is full model. So, now if we go by stepwise. So, in the step 1, so the most important variable is here coming as a floor, right. So, that means let us in the step 1. So, there is a particular variable which is coming actually, let us say fourth variable is coming as a most significant variable. So, x 4 is the first model. So, ultimately your model outcome will be beta 0 plus beta for x 4, and then you will have r square, adjusted r square and f. Then I am very sure in the multiple contest x 4 is coming very high impact and it is highly statistically significant. So, as a result, when you estimate the dependent variable again with respect to that variable, that independent variable only, then the impact will be much higher again. So, as a result, by default this beta 4 will be statistically significant and will give you r square value and also adjusted r square and f. In the first instance we need not require to compare, but now you go to the step 2. In the step 2, the next most important variable which is on the basis of t statistics. So, that means technically you just put ascending to descending order the impact highest t to lowest t. So, that automatically give you the impact of a particular variable to the dependent variable. So, now let us say that x 2 is the next one which is having high impact to the dependent variable after x 4. So, then the next step your model will be y equal to f of x 4 and x 2, and then finally your model estimated model will be beta 0, beta 4 and beta 2, and then we have adjusted r square and f. Okay. So, now since already beta 4 is statistically significant. So, here you check whether beta 4 is still statistically significant or not, and again beta 2 is coming statistically significant or not. If beta 4 statistically significant and beta 2 statistically significant and r square is improving compared to the first one, because you are adding another variable, r square is improving, by default it will be improving, but what is important is to check adjusted r square whether it is increasing compared to the previous one, and f will be also increasing, and that too f should be statistically significant. If this is significant, this is significant, this is high, this is high, this is high, then technically this model can be considered as the best compared to the previous one. So, now between these two models, this will be now rejected and this will be finally accepted. Again this is not the ultimate model, then because there are more number of variables are there. So, now you will check what is the next variable, which one is the next most important variable to predict the y. So, let us assume that it is a x 3 again. So, then you go to the step 3, then your regression will be y versus x 4, x 2 and x 3. So, again so beta 4, beta 2 and beta 3, and again so what will you do? So, you have to check the significance level, and significance level, and then R square, adjusted R square, and adjusted R square, and then F. So, if you find all these coefficients are statistically significant and R square is high, adjusted R square is high, and F is becoming statistically significant, then this model will be considered as the best compared to the previous one, this one. So, then in that case this will be rejected and this will be finally accepted to predict y, and that too with respect to x4, x2, x3. Then again in the step 4 you will check which one is the again most important variables as per the ordering, and that variable again included into the system and estimate the process, and then check whether the variables are still statistically significant, R square is improving, adjusted R square is improving, and F is improving. And if that is the case, then you keep that model, and then the previous model will be by default rejected. But after adding another variable, new variable, let us say x1, and the impact of other variables start declining and not significant, and then R square, adjusted R square is declining and F is declining. In that case, so you have to stop, and then you can reject this one. Then previous model is already declared as the good models, and that can be used for the prediction and forecasting. So, this is how the forward process. In the backward process, you start with full model, and then check which one is the least impact to the dependent variables. For instance, in this case distance is becoming the least variable. So, you have to re-estimate the model by dropping the distance component, and then have the estimated output. Now, this is the original output. Then after dropping the distance, you will find another set of the output. Now, you compare. In this case, how many variables are significant and at what level? Again, so you have to see how many variables are statistically significant at what level. So, that means, if dropping distance and your model still most of the variables are statistically significant and R square is R square, adjusted R square, and F is coming fair enough, then in that case the second model will be best, and then you reject this one. And again you can go ahead with the dropping another variable which is least impact, and then again re-estimate, and then check the results to the previous ones and compare which one is the best. If the model is improving, obviously if you unnecessary variable if you drop, then adjusted R square will start increasing, the impact of variables will be very high, and again the F statistic will be statistically significant and also very high. So, now you will continue and continue in such a way that the next entry or next dropping will actually affect the estimated output compared to the previous ones, and that is the stopping point, how to stop or how to get the best models on the basis of backward operation and forward operations. So, you start with the full and drop remove one after another till you get the optimum model, which is actually good for the estimations, prediction and forecasting, where all the variables are statistically significant, supported by adjusted R square and F. And in the on the other side, in the case of forward process, you add one after another variable, and sometimes you check whether the variables are coming statistically significant, and that to improve the model with respect to adjusted R square and F. And you will stop at a point where the variables impact will start declining, and adjusted R square F value will also start declining. So, in that context you have to fix, you have to stop and then use that the previous model for the prediction and forecasting. So, that means, this very interesting technique to get the estimated model by the process of eliminations or something like that. So, that the estimated model can be declared as the best models, or line of the particular line will be declared as the line of the best fit, and which is means very easily, or you can typically use for the prediction and forecasting as per the particular engineering problems requirement. So, this is all about the multi-component issue. So, till now we have discussed what is that exact problem and how to detect this, how to solve this, and what are the regions through which multi-component is coming. That itself will give you the indication about the kind of revisit the process, restructure the process, and then finally you get a estimated model which is actually very useful for the prediction of the y, and that too within high accuracy and high reliability. This will stop here. Thank you very much. Have a nice day.